All right, so in an electrical circuit, there really are only two things that you need to keep track of. So these two things are the voltage and the current. So the voltage is that type of gradient that causes electrons to flow in one direction. They tend to want to flow from a region of higher voltage to a region of lower voltage in this case. And when it comes to current, is actually the electron flow that's a result of the voltage. In fact, there's actually a relationship that corresponds the voltage to the current, which is called Ohm's law. What this states is that the voltage is equal to the current times the resistance of your component that you have in your circuit. So the instance with this one, with the battery model, we have a voltage gradient over here, but what limits the current is actually the inherent resistance of this light bulb. So the filament has a resistive property, and because of that, there's a limited amount of current. And so as you can see right here, with a greater amount of resistance, you have a reduced amount of current if you have a constant voltage, and vice versa. Now, with the water analogy or hydraulic systems, voltage and current kind of correspond to these two things called pressure and flow rate. So like voltage, which is the gradient that causes electrons to flow in a specific direction, pressure is that gradient that causes water to flow in a specific direction. So in the case with the heart, you can see that when it pumps, the heart causes this sort of pressure, which causes the blood to flow in a specific direction. And with that in mind, the flow rate is the actual movement of the water in the heart, or the case with the case of the heart, it's more of blood. So the blood moving in the heart in a specific direction. And like the Ohm's law, there is a formula that describes the relationship between pressure and flow rate, which is Poiseuille's law. Which states that the pressure is equal to the flow rate times the intrinsic resistance of your tube. So if you have a thinner tube, you have a greater resistance, it's going to decrease the flow rate. If you have a wider tube, it's going to allow a greater amount of flow. So, and also in the context with this, in terms of metrics or the units, pressure is typically something like pascals. Flow rate is typically something in meters cubed per second. And with the case with voltage, you just simply have volts, and for current, you have something called amps. So voltage is something like volts. Oh, wrong color. So voltage is typically something with volts. Current is typically something with amps. And so these two things kind of actually work hand to hand.